See, this is our syllabus for the drainage design calculation. Today we will discuss about condensate drain calculation, right?
Yes, sir.
Okay, if you go to our IPC standard, okay, there is one chapter called general regulations. Okay,
Okay.
general regulations. So in that, if you go down, you will find one section called for condensate drain, right? So you can hear condensate disposal. Okay, so here you
Okay.
can see that basically the condensate drain system shall be provided for equipment and appliance containing evaporators or cooling coil, right? So whatever the coils or evaporators, okay, that will condensate. Okay, whenever it goes to the low temperature, that will condensate, right?
Hmm.
To dehumidify the air. Okay, so this is basically the principle of air conditioning. Okay, why the water is condensate, right? Say for example, you're going to use one fan coil unit, all right? In the fan coil
Yes.
unit, you know that there is on coil temperature and off coil temperature, right?
Hmm.
Okay, the on coil temperature basically from the room temperature, or basically it is coming from outside or from the any of the return air, right, from the space. Okay,
Okay.
so that will go into the coil. Okay, so when it goes to the coil, that will lower the temperature to the low temperature. Okay, it will cool the air by low temperature so that it can dehumidify the air. Okay, why it has
Hmm.
to dehumidify? It has to remove all the moisture content from the air so that the when the air goes into the space, there will be no humidity or no moisture, right?
Hmm.
Okay, so that is what you are going to cool the air at low temperature so that you can remove the whatever the moisture in the air. Clear, right? Okay,
Yes.
so whatever that moisture, it will be collected at the condensate drain pan, and that will be taken out from the air conditioning equipment, basically, right?
Hmm.
Okay, then it will be piped to the nearest flow drain, or you can collect all the condensate drain pipe. You can connect to the manhole directly in the below network, or you can collect all the condensate drain. You can store it in a condensate drain or condensate disposal tank. Okay, then you can use it for other uses. Say for example, you can use the condensate drain for irrigation purpose, or you can use that condensate drain for the urinal or wash basin for the recycle, right? Okay,
Hmm.
so this is the purpose basically, right? That is the condensate basic introduction. Okay, now if you talk about the chapter 3, okay, you can see that condensate drain sizing. Okay, you can talk about here up to 20 ton of refrigeration, you can use the pipe 3 by 4 inch, right? The pipe size.
Okay.
Okay, then you can see that over 20 tons to 40 tons. Say for example, when you talk about 20 tons, how many kilowatt? Okay, so you can say that 20 ton is nothing but 20 multiplied by 3.56. You can say around 71.6 kilowatt. Up to 71.6 kilowatt machine, I can use 3 by 4 inch, which is nothing but 20 mm, right?
Yes. 20.
Okay, so up to 70 kilowatt, you can use 20 mm. Okay, say for example 40 tons. So 40 is nothing but 40 into 3.56. I can say 142 kilowatt. I can use up to 1 inch pipe size, right? So this is
Hmm.
the pipe sizing. Okay, here it is direct. Okay, it is not like a HVAC that you have to calculate many things. Okay, here you will get the answer directly based on the kilowatt. You are going to do the pipe sizing, right?
Yes.
Okay, so this is the table, condensate drain table. But to understand the basic, how this pipe size arrived, okay, that also I can explain you as a basic concept. Okay,
Okay.
okay. Now remember, there is one equation from the HVAC. Okay, uh, you can say that is called condensate drain equation. You can see this formula, right? GPM air conditioning equipment is nothing but CFM multiplied by delta W divided by specific heat multiplied by 8.33, right?
Okay.
So this formula came from where? Basically from the air conditioning principle. Okay, say for example, this is the GPM of the condensate drain. Okay, and this is the
Hmm.
CFM of the air conditioning, the air flow rate of the air conditioning equipment multiplied by delta W, which is nothing but humidity ratio.
Hmm.
Okay, they divide by specific volume multiplied by 8.33. Okay, so this is the equation, right? So this equation, how to calculate the airflow rate? Say for example, since you are a air conditioning background, you know that whenever you have a schedule of the air conditioning equipment, what are you have? So you have a fan coil unit, okay, and what you will have, you have airflow rate, which is in liter per second or meter cube per hour, right?
Yes, sir.
Okay, then you have on coil temperature. So say for example dry bulb temperature and wet bulb temperature, right?
Hmm.
And then you have off coil temperature, which is dry bulb temperature and wet bulb temperature. This is from the FCU equipment schedule or AHU equipment schedule.
Okay.
Okay, now if you go to the psychometric chart, okay, say for example, I have a dry bulb temperature, when I have a wet bulb temperature, can you calculate how much moisture content, humidity ratio, right?
Yes. Yes.
Okay, say for example, if I go to one of the calculator, psychometric calculator, so if I go to psychometric calculator, I'm going to enter what is the dry bulb temperature, which is 24 degree Celsius, and wet bulb temperature will be 17 degree Celsius. When I do calculation, I can able to get what is the humidity ratio, right?
Yes, sir.
So this is the humidity ratio. This is kilogram per kilogram. Kilogram of moisture per, per kilogram of dry air, right? Like how much water, okay, in the moisture air per kilogram of dry air. So this is the formula. So when you see here, you can see 0.0092, right? Kilogram per kilogram.
Yes, sir.
Okay, based on the on coil temperature. Okay, similarly, based on the off coil temperature, say for example, I have off coil temperature which is 14 degree and 13.4. So what I'm going to do, I'm going to enter 14 degree and 13.2. Okay, so when I calculate, I will be getting humidity ratio of off coil temperature, off coil condition, right? So this is my off coil condition temperature, right?
Yes, sir.
Okay, and what is the specific volume? Again, I will go to the psychometric chart. I can able to get what is the specific volume here. Can you see that specific volume?
Yes, sir.
0.825 meter cube per kg, right?
Hmm.
Okay, so I'm going to enter the value here, specific volume. Okay, so when I calculate density, what is the definition of density? It is like a 1 by specific volume. Okay, clear, right?
Yes, sir.
Okay, then now what is the equation now here? If you go in this equation, you are going to calculate GPM of air conditioning condensate drain in GPM is equal to CFM multiplied by delta W divided by specific volume multiplied by 8.33. So you have a CFM from the chart. You have a CFM here or liter per second here or meter cube per hour here. Correct?
Yes, sir.
Okay. Now then what you require? You require delta W. Delta W is nothing but difference in moisture. So if I see calculate this value, can I get difference in moisture x minus y?
Yes, I
Okay,
understand. Yes.
clear, right? So now what is the equation now? Again, next divide by specific volume. So specific volume we got it from the psychometric chart, right?
Yes, sir.
Okay, so when I apply this equation, I will get total how much moisture removal. Okay, how much moisture removal in kg per hour, or I can calculate moisture removal in liter per second. How I will calculate? A is nothing but density multiplied by B. B is nothing but difference in moisture multiplied by W, which is CFM, right? So when I calculate all three, then I will get total moisture removal rate, which is called condensate drain. How much moisture I have removed in kilogram per hour. If I convert into liter per second, I can say moisture removal in liter per second, right? So this is the condensate drain flow in liter per second. Similarly, for if you want to calculate for FHU, based on the liter per second, based on the dry bulb temperature, on coil temperature condition, and based on the off coil condition, I can calculate moisture content based on psychometric chart. I can calculate the specific volume. Then I will calculate my what is the density. Then when I can calculate difference in moisture. So what is the equation to calculate your moisture removal? It is nothing but CFM multiplied by delta W, which is moisture, divide by specific volume or multiply by density. Both are same, right? So I will get the moisture removal rate in liter per second or kg per hour. So this is my flow rate, right? Okay, so this is my flow rate. So when you see this particular flow rate, it is very small, right? Say for example, if I go to one of the standard DS standard, then can you see the velocity? How much velocity applicable in the drainage system? Capacity of drains. What is the velocity? Normally we can go like 0.5 meter per second when you have a slope of 0.5 centimeter per meter. Okay,
Okay.
and if you have a slope of 5 centimeter per meter, you can go up to 1.6 meter per second, right? So this is the velocity of the drain pipe. Okay, so if you go to this particular Excel sheet, okay, so this flow, can you see it is not even 1 liter per second, right?
Yes, yes.
Okay, so up to 17, say for example here, how much kilowatt, you can calculate the kilowatt by using this equation, right? Maybe it is very small kilowatt, very small capacity. Okay, so up to 20 ton, I can go with the 20 pipe size, right?
Yes.
So you can calculate the flow rate based on the velocity. You can able to calculate what is the pipe size, right? So here you can see the velocity here. Okay, so I'm going to calculate the flow rate. So here this is the flow rate. So based on the velocity, I can able to go with the pipe sizes, right? Okay, so here it is 100 Okay, at 125 So for 100 up to this much, I can go with the velocity, right? Okay, clear, right?
Yes,
Selva,
sir.
how to
Yes.
calculate the flow rate? Okay, so sometimes, say for example, I'm going to collect all the condensate water. I'm going to store it in one tank. Okay, so what I can do, I can say that I can calculate based on number of working hours, how much the air conditioning will be worked. So how much condensate water I can collect based on average hours. Say for example, I'm going to calculate for 24 hours, 0.7 factor or 0.5 factor only, say for example, my office will be working only for 12 hours, right? So 12 hours my air conditioning will be operating. So based on 12 hours, say for example, I have so and so equipments. Say for example, this is my total moisture in one FCU multiplied by 12 hours. Okay, so I can get total this much liters, right, per day. From FHU I can calculate so and so liter. Okay, so this much liter I will get from condensate drain. So I can store all this water and maybe I can reuse it, right? Say for example, I have a 49,184 liter available per day. Okay, so this
Okay.
water I can use it for, say for example, I can use it for WC, or I can use it for irrigation, or I can use it for urinal purpose, right?
Yes, sir.
Okay, so this also you can plan it. So say for example, if I go to one of the layout, right? So this is one of the project. Okay, in this project, what they did not use any uh, condensate drain tank. What they do, they have collected all the tanks. You can see the tank pipe size, right? 25 pipe size. So this pipe size from where? From this standard.
With
From this standard, right?
the table. Yeah, sir.
Yeah, in this table you have a kilowatt, right? You have a kilowatt, and then you can use the pipe size directly, right? Say for example, you have a 20 to 40 tons, you are going to use 1 inch. Okay, so here you can see based on this particular capacity, they are going to use 1 inch, right? 25 Some consultant they may use like which is higher. Okay, say for example, maybe as per the standard 20 but they will use 25 for some safety purpose, so that there will be no leak, blockage, or just considering some safety factors, right?
Okay.
Okay, so here you can add both the kilowatt, then you can able to calculate the pipe size, how much pipe size, right? Okay,
Yes, sir.
so like that they are going to collect all the drainage, all the condensate drain. See here, all the condensate drain they are going to collect it here, collect all the condensate drain. So this pipe size is based on what? Based on the tonnage, how much tonnage of the equipment. Okay, so you are going to collect all the waste condensate drain from everywhere, then you are going down to the shaft. Okay, so this shaft will go down, then you can see that further below layouts. Okay, can you see here, it is going to the gully trap directly. Okay, then it will go to the manhole, right?
Yes, sir.
So okay, so far what we have seen the sewage water comes from where? From the toilet. Okay,
Toilet.
the sewage water will be divided into two types. One is the soil water and another one is the
Waste water.
waste water, right? The soil water comes from urinal or WC. The waste water
Yes.
comes from wash basin, shower, or floor drain, right? Okay, so you have a two pipes. One, all the soil pipe will be connected to the manhole directly, right?
Yes.
Okay, then you can collect all the waste water. Okay, goes to the manhole by means of gully trap. Okay, what is the purpose of gully trap? To remove all the smells or whatever to prevent any gases, right?
Yes.
Okay, then if you have any waste material, if it which is stored in the pipeline, it can be removed from here by using the gully trap, right? Then
Yes.
the clean water will go to the manhole. Okay, then similarly we have seen that storm water pipe, right? The rainwater, whatever it collected from the building, it will collect all the rainwater, then it will go to the manhole directly. That is called storm water manhole. Okay, so you have
Yes.
a sewage manhole separately, then you have a manhole for
Stone
storm
man.
water separately, right?
Yes.
Okay, now the condensate drain pipe, either you can connect to the storm water or you can connect to the sewage water, right? Whatever is
Yes.
nearby.
Yeah.
Okay, so condensate drain can be connected any of the storm, any of the manhole, either storm or sewage, depends upon whatever the nearest manhole availability, right?
Yes.
Okay, so you can see that all the storm water is connected from all the AC equipments. Then you are going to connect it to the gully trap. Then it will go to the wastewater manhole, right? Sewage manhole. So this is one type. Okay, I don't want to waste all the condensate drain water. So what I can do, I can go with the storm water manhole, or sorry, not stormwater manhole. I can say condensate drain water tank, right? So I can go with one small tank. Okay, based on my calculation, every day I can get 50,000 liter, right? If I round off, so which is
Yes.
nothing but 50 meter cube, right? Can I say 50 meter cube?
Yes. Yes.
Okay, so this based on this 50 meter cube, I can calculate my water tank, right? Say for example, I can calculate, uh, say for example, 10 multiplied by 2 multiplied by 2.5. Okay, correct?
Yes.
So I can go with the 10 meter length and 2 meter, or I can go with the 5 meter by 4 meter. Okay, then 2.5 meter height. Then for safety factor 1.1. So this is my tank. So my tank can be 55 meter cube considering
Yeah.
freeboard, right? So I can collect all the wastewater from all the condensate drain in this particular tank. Then I can reuse it. I can treat that water, then I can reuse it, right?
Yes. Yes.
Maybe I can use it for irrigation purpose, or I can use it for
Plus tank.
a flush tank or urinal, based on that. So if I know the flow rate, I can calculate, I can reuse it. Clear, right?
Yes.
Okay, so this is the condensate rainwater calculations basically. You have any
Okay.
doubts?
One more question, sir.
Yeah, yeah.
If you have a number of units in one floor, like
Okay,
if you have a 10 units,
okay.
we cannot take the condenser drain for like parallelly 10 units. We have to split the pipe sizes for like 5 units. We can take out the condensate pipe for 5 units, and another 5 units we have taken a CDP pipe for separately, right? The maximum
No.
branch pipe will be 65, I think. Or
For the condensate drain pipe, maximum pipe size will be 65.
yeah, just I'm asking.
No, I can see in this diagram. See, we have a 25 pipe, we have a 32 50 right?
Yes, yes.
Then I can
I'm
see
talking about
here,
maximum.
yeah, maximum. See, I can. That is what I'm going through here. See, I can see here maximum 65 pipe, right? This is
Yes, yes,
65 CDP. Then going to the riser. Then I can see here 100 CDP, right?
yes. Riser
So
it's okay, but the branch pipe, whatever it's coming inside the building, the CDP pipe, it should be up to 55, yeah, up to 65 dia.
okay, is there any reason?
No, it's just I have worked on multiple projects. They didn't use above 65 for the CDP drain pipes. I don't know why they are
Okay.
calculate that much, but just I want to know why we can't like use 100 or 110 something like that in the inside the building.
See, maybe you cannot run inside the building with a larger pipe because it may affect your false ceiling. That may be the reason, right?
Okay.
Okay. If you use bigger pipe, that may affect your false ceiling or spaces above attic spaces. So that is why they may limit, but there is no such restriction in the code. Yeah, that you have to use only up to this pipe only, something like that.
Okay. Okay.
Okay,
Okay.
that depends upon space availability, right?
Okay. Okay.
So,
Sir.
but there is no condition that you have to use only up to this pipe only, something like that. No, it's not like that.
Okay.
Okay.
That's the my question. Yes.
Yeah. No, it doesn't. Maybe depends upon your space availability. You have to see how much space available in your above ceiling. Okay, maybe they think that if you use bigger pipes, it will affect your attic space.
Yeah. Okay.
That is only the
Understood.
reason. Clear, right?
Yes.